Hello everyone, my name is Swapnil and welcome to this in-depth exploration of the network layers and protocols used in the IoT ecosystem. Today we shall be covering some of the most important protocols that enable communication and connectivity between IoT devices, including the Internet Protocol IP as the network layer and some of the critical protocols built on top of it such as 6LoWPAN, 6LO, 6TiSCH, RPL and DODAG tag. Let's start by looking at the IP network layer. As you may know, IP is the fundamental protocol used for communication on the internet, and it also plays the critical role in IoT networks. IP enables devices to communicate with each other across different networks using unique IP addresses to identify each device. In IoT networks, both IPv4 and IPv6 are used. I don't prepare any PPT for that, so I am using this website. It gives me some all the protocols. So you can see this. This is the IPv4, which is the version 4 of IP. In IoT networks, both IP4 and IPv6 which are used. IPv4 is the older protocol and is still widely used, while the IPv6 is the newer protocol designed to replace IPv4 and provide more addresses for the growing number of devices on the internet. This website you may see, you can see search on the Google as well. So that's it from the IP, and I will discuss now for the 6LoWPAN. In this where is the 6LoWPAN security measure, that is the security measure, and this is one such protocol built on top of IP is the 6LoWPAN, which stands for IPv6 over low power wireless personal area network. 6LoWPAN is designed to enable low power wireless communication for IoT devices using the IPv6 protocol. It helps to minimize the packet overhead and enable the efficient routing in low power and lossy networks, that is LLNs. It achieves this by compressing and fragmenting IPv6 packets as well as using header compression and other techniques to reduce the packet size. That's it in the 6LoWPAN. But you can see this 6LoWPAN protocol is able to IPv6 low power personal area network, that is the 6LoWPAN. It has header compression, fragmentation, and link layer forwarding. IPv6 supports packet header length of 127 byte. So 6LoWPAN defines header compression for IPv6 for decreasing the overhead, that is the power will be less, so that is the low power. That's why it is called as decreasing the overhead. Fragmentation, the minimum MTU size, that is the maximum transmission unit of IPv6 is 1280 bytes. On the other hand, the maximum size of frame is in the IEEE 802.15.4 is 127. Therefore, the IPv6 packet need to be fragmented. That is the most required part in this 6LoWPAN, which is optimized from the IPv6. Now we will discuss about the 6LO. What is that 6LO is? In this website, is it 6LO here? Yes, here is the 6LO, which is developed by the IDF group. You know this Internet Engineering Task Force, that is the IDF. 6LO is the extension of 6LoWPAN, that is adds additional feature for compression, fragmentation and the header compression. These features help to reduce the packet size and improve the efficiency of the network. 6LO also provides the support for multicast communication and neighbor discovery, which are important features in the IoT networks. IPv6 networks rescue constrained nodes is in the IPv6 based network access protocol for data links that were left excluded by the 6LoWPAN. It is the optimization of 6LoWPAN and 6TiSCH that is called by this website. So it is, for example, IPv6 standardization over PLE, NFC, IEEE 802. This is the IEEE standard. I don't know what is this called in our language, but it is IEEE standard, and many other macro layer protocols will be included in this standard. IP6A6 over Bluetooth low energy. Oh, that's is this Bluetooth? I don't know, but they call this as IPv6 over Bluetooth low energy. Now we will move forward with another protocol, that is 6TiSCH. What is this 6TiSCH? In this time slot will be there. So let's see what is the 6TI. No, it is also developed by the IDF, that is Internet Engineering Task Force. Another important protocol in the IoT ecosystem is 6TiSCH, which stands for IPv6 over the time slotted channel hopping, that is TSCH, that is the time slotted channel hopping mode of IoT IEEE 802.15.4e, that is the IEEE standard. You can search it. It is designed to provide deterministic communication and time synchronization in industrial IoT networks, which require high reliability and low latency. As this provide you low latency, so you can use it in the audio or video streaming platforms, so that it gets low latency. But in this it is not better option because it can lose some packets, as it uses these low networks, LLNs, so low power lossy networks, that losses the packets actually. So 6TiSCH uses time slots to enable the communication between the devices, and it also provides mechanism for security and reliability. As you can see, this also provide you security, that is good for you as well. Now we will discuss about the RPL. The main part is RPL, where it is RPL is also the good protocol. RPL stands for routing protocol for low power and lossy network. These all are made for the low power. You can see this low power. Why this is made for low power? Because some IoT devices require low power. For that, you can use this protocol. It is a distance vector protocol that supports a variety of data link protocols. It is the routing protocol designed for LLNs, which uses the hierarchical routing structure based on the destination oriented directed acyclic graph, which is DODAG. DODAGs are formed by choosing the root node and creating links between the nodes in a tree-like structure. DODAG is that. This allows for efficient and reliable routing in LLNs, even when the network topology changes frequently. Now we will see what is the DAG and DODAG. As we will we see here that destination oriented directed acyclic graph. So we will discuss the DAG and what is DODAG. Here it is. Where is the DAG and DODAG? So they didn't give you the what is DAG and DODAG, but I will discuss it some and little bit information. I know that DAG and DODAG, it is a similar data structure. DAG is the similar data structure to the DODAG. That is the but it is not. It is used in the non-hierarchical networks. In the DAG, nodes are connected to each other in mesh network. In mesh network, you know that mesh network. What is that topology? In DAG, nodes are connected in each other in mesh network, and routes are determined by dynamically based on the state of the network. DAGs are used in the IoT networks where the topology is more fluid and there is no clear root node. That's it in the DAG and DODAG point. Now we will conclude this video with conclusion that the network layers and protocol we covered today are a critical component, and in the IoT ecosystem, by combining IP with protocols such as 6LoWPAN, 6TiSCH, RPL, then we discussed DODAG and DAG. We can build efficient and reliable IoT ecosystem from this. That's it in this video. Now bye bye, and let's meet in another video. Now I will upload my videos regular basis with 1 or 2 days delay, but not that much delay like 1 month. Thank you for watching.